So for this method, we will be using this definition of ellipse. We start with draw both the axes as usual and name the endpoints like this. Taking AO or BO as the distance, that is half the major axis, and C as center, draw two arcs. So we will be able to locate the two foci points F1 and F2. Now our point P moves in such a way that the sum of the distance of point P from F1 and F2 remains constant, and that sum has to be equal to the major axis AB. So we start drawing now. On the line F1O, taking any distance, mark the point 1, 2, 3, 4. Locate any number of points at any distance, that is totally your freedom. So I have located 4 points, point number 1, 2, 3 and 4. You can take any number of points at any distance. Now the most important, taking F1 as center and the radius equal to A1, draw an arc. So A1 is the distance or the radius and F1 is the center. We draw an arc, and then taking B1 as the radius and F2 as center, draw another arc. So these two arcs will intersect at a point. I'll call this point as P1. So the distance of P1 from F1 is equal to A1, and the distance of P1 from F2 is equal to P1. So the sum of the two distances P1 F1 plus P1 F2 is now equal to A1 plus P1, that is equal to AB. So this satisfies my requirement of the ellipse, that the distance of the point P from two fixed points F1 and F2, the sum remains constant and equal to the major axis AB. So this is how I have located point P1. Now similarly take point 2, repeat the steps with the same center, but now take A2 and B2 distances from the drawing the arc. The arcs have to be drawn with F1 and F2 as centers. The distances have to be taken as A2 and B2. So we locate another point P2. Now take the distance A3 and B3, draw two arcs. Then take the distance A4 and B4 and draw two more arcs. You will get 4 points P1, P2, P3 and P4. So this is 1/4 of an ellipse from A to C, passing through P1, P2, P3, P4. Similar construction on all the sides, we will get all the points for the ellipse like this. So I'm not drawing them one by one. This way you can locate all the points and then join all those points with a smooth curve. You will get an ellipse. Note that the distance A1 plus B1 is equal to A2 plus B2 is equal to A3 plus B3 and so on. And all these sum of the distances are equal to AB, the major axis. That is the requirement as per the definition of the ellipse here. That is the requirement. The sum of the distances from two fixed points F1 and F2 remains constant and equal to the major axis. So now we move on to the next. Draw a rhombus and inscribe an ellipse in it using 4-center method. This method we will be using most frequently because it's a very simple method, and unfortunately this method gives us an approximate ellipse. But if we have to draw a number of ellipses, so this method can be used. This gives us an approximate ellipse. Okay, so first draw a rhombus of the given dimensions and draw its diagonals. So this is the rhombus of the given dimensions and the angles, and we have also drawn the diagonals. So this is the smaller diagonal of the rhombus, vertical line, and the horizontal line is the bigger diagonal of the rhombus. Mark the midpoints of all the sides and name them A, B, C, and D. Now here A, B, C, D are not major and minor axes. Any 4 points, I'm calling them A, B, C, and D. So the midpoints of all the four sides, midpoints of this side is A, midpoint of this side is B, and so on. After this, join these points to the ends of the smaller diagonal. Now this is the smaller diagonal. So this is one end at the top, this is the other end at the bottom. So this bottom end joined with A and B, and the top end joined with D and C. Join the midpoints of the edge sides of the rhombus to the ends of the smaller diagonal. So now I have 4 points. This method name is 4 centers method. So I will require 4 points which will be used as centers. So one center is this point, the top end of the smaller diagonal. This is the second center, that is the lower end of the smaller diagonal. This point is the third center, that is the point of intersection of these two lines, and similarly this point is the other center. So now we have point number 1, 2, 3 and 4 as 4 centers. So in this method we have to first locate the position of 4 centers. That I have located point number 1, point number 2, point number 3 and 4. Now 1 as center and 1A as radius, draw an arc. The distance 1A is equal to the distance 1B. So if I draw an arc with 1 as center and 1A as radius, it will reach up to point B. Now similarly take point 2 as center and 2C as radius. 2C is equal to 2D. So we draw an arc, we get another arc C and D. Now take 3 as center and radius equal to 3D or 3A. Similarly take 4 as centers and radius equal to 4B or 4C. Draw 2 more arcs. So this is a required approximate ellipse. Actually it is not an ellipse, but it is actually 4 arcs of circles. So this is not an ellipse, but it is an approximate ellipse, and this can be drawn very quickly. So we can draw ellipse using this method if we do not require a perfect ellipse. If we require a perfect ellipse, we cannot use this method.